Good day, third classmen. So today we will be making an orthographic projection. So we will be needing triangles, your 45 by 45 triangle and your 30 by 60 triangle, protractor for measuring angles, straight edge, technical compass, and pencil or ball pen. Okay, so let's start. Suppose we are given latitude of 20 degrees north and declination of 30 degrees north also. So from the declination, we can conclude that the celestial body is not a sun, because the maximum declination of a sun is 23.5 degrees north or south. So definitely this is a planet or a star. So let's consider a star for that matter. And so our meridian angle of the star is 50 degrees east. So just like with your time diagram before, these values you will be given later on with LHA, meridian angle, azimuth, true azimuth, altitude, right ascension, sidereal hour angle, and you will find out this value. So from time to time, you will be given some other values. Okay? So we will be required to find your first azimuth, next your true azimuth, and finally your altitude. So as I have said, later on you will be given these values and you will try to find these values. Okay, let's start. So first, establish your center point. So let me establish mine. Okay. So this is my center point now. I will make a circle, so not so big and not too small also. So just enough so that I have a space here, because later on I will use this part for projections. Okay. So this circle will be now your celestial meridian. Okay, so let's name it. It's your celestial meridian. Okay, and your vertical line here is your prime vertical circle. So if this is your prime vertical circle and this is your celestial meridian, therefore this is your zenith now and this is your nadir. Okay? And this horizontal line here is your, this will be your celestial horizon. So here will be your north direction and your south direction. So after drawing these lines and circles, you are ready to plot your latitude. So we are given a latitude of 20 degrees north. So how do we plot that one? So from your horizon, using your protractor, measure 20 degrees north. So if it is south, you plot here. Okay, so since this is north, I will make an angle here of 20 degrees. And then I will connect the center point and my marking passing the celestial meridian. Okay, so this is now my north celestial pole and south celestial pole. So this is your axis now of north celestial pole and south celestial pole. So this is 20 degrees north. So this is your elevated pole and the depressed pole. Then after plotting your latitude, make a line perpendicular to your north and south celestial pole axis. So I will make your I will use of my protractor. Perpendicular, this will be my QQ or your let's name this QQ as your equinoctial or your celestial equator. Now we have declination also. So based from the definition of declination, it is the angular distance from equinoctial towards the celestial body. So from your equinoctial, we will measure 30 degrees. 30 degrees north. So I will plot on the upper side of your equinoctial because it is north. If it is south, so you will plot definitely below the equinoctial. Okay, so 30 degrees, 10, 20, 30. I will mark here and then plot. So this will be my declination now. Here, this angle is my declination. So that is 30 degrees north. I will make a parallel line with this equinoctial passing through that intersection of your declination and the celestial meridian. Okay. So this will be the parallel of declination. This is not a declination. This is the declination and this is the parallel of declination. Parallel to the equinoctial. Okay? After that, I will make a semicircle with this center, the intersection of your parallel of declination and the north and south celestial pole axis. With this radius, I will make a semicircle. Okay? And from here, I will plot the meridian angle of the star. Meridian angle is 50 degrees east. Now, it is named east. This is your north celestial pole. So, everything on the right side will be east and everything on the west side will be west on the left side. So, I will plot my meridian angle here. And from this meridian angle, I can conclude that the body is rising because of its direction. 50 degrees. From the parallel of declination, I will measure 50 degrees. 10, 20, 30, 40, 50. Mark. And then from the center of your semicircle, draw a line connecting these 2 points. So this will be my meridian angle now. 50 degrees east. This is my declination. This is my latitude. So after doing that, the intersection of your meridian angle and that semicircle, bring this point down to the parallel of declination. So how will we do that? You can do this one. Okay. And along this declination, this parallel of declination, somewhere here, this is the location of your celestial body now. Star. Okay, so we are ready now to find out your altitude. So first, draw a parallel line passing through that position of your celestial body parallel to your horizon. Okay, so that will be your altitude measured from your celestial horizon to the celestial body. That is the altitude. So you can measure here or in this side. So since this is somehow crowded now, I will make use of this because this angle is also equals to that angle if I will draw here. Now, we'll measure it. So, my altitude now is exactly 10, 20, 30, 40, 45. The altitude of the body is 45 degrees. Okay? Next, to find for your azimuth and true azimuth, we will extend this prime vertical circle first because this will be your reference. Okay, that's enough. Okay, so using your parallel of altitude, this line, draw again a semicircle with this intersection of the prime vertical circle and your parallel of altitude. Draw your semicircle. So this is where we project our azimuth. So draw a line parallel to the prime vertical circle and slide towards the body until it intersects with the celestial body and the semicircle. Okay. Let me mark that one for the moment. And then I'll project here. Okay, so this will be my true azimuth now, this angle. So where is your north direction? It is here. So they are parallel with this line. So I can say also that this is also a north direction. Okay, so measuring it, my true azimuth now will be 10, 20, 30, 40, 50, 60, 65 degrees. True azimuth is 65 degrees. Okay? So, true azimuth is measured from your true north in a clockwise direction through 360. Okay, so how to find for your azimuth now given your true azimuth? So if we will recall from your previous subjects, I hope this was already taught to you. So let's anyway, let's try to review it. So given your quadrant, so your north, east, south, and west cardinal points. So in this first quadrant is your northeast, southeast, southwest, and northwest. So again, your true azimuth is measured from your true north clockwise direction through 360. And then, what is your 65 degrees? So your true azimuth is 65. How will you find for your azimuth? So let's try to plot 065 degrees true. Can be located somewhere here. True azimuth 65. And then, for your azimuth, express this true azimuth into quadrantal. Okay, quadrantal form. So, northeast, let's try to do like this. And then, put here. So, you read this as 65 degrees east of north. So, east of north, west of north. Okay, so this will be your azimuth now. 065 degrees east of north. So, since it is located on the first quadrant, they are the same. But, your azimuth has directions east of north. Okay, so let's try to complete this thing. So suppose you are given true azimuth equals to 110 degree true. So let's plot here 110, this is 90, so plus 20 degrees. So this will be my true azimuth, 110. So it is located in the second quadrant. So if this is my true azimuth, therefore this is my azimuth. Okay, so how do I name that? So east and then south. What angle is this? This is 20, this is 70. So 70 degrees east of south is equals to 110 degrees true. Okay, so now let's try to do the other opposite of that process to find out for your true azimuth. So suppose your azimuth is, let's say, 40 degrees west of south. 40 degrees west of south. What will be the true azimuth? So true azimuth from north clockwise direction going here. So this is 180 plus 40. 180 plus 40 equals 220 degree true. So your true azimuth equals 220 degrees. And finally, for the fourth quadrant, suppose you are given an azimuth of, this is west, this is north, an azimuth of 20 degrees, let's say 20 degrees. 20 degrees west of north. So this is the west of north, east of north. Therefore, your true azimuth will be starting from your north direction, clockwise till here. So I can simply 360 subtract with 20 degrees 0, this is 4, 340. So your true azimuth is 340 degrees true. So I believe it was already taught to you. So let's go back to your orthographic projection. Okay, so aside from this, sometimes you will be asked for your LHA of this star. So you can do with the nautical almanac, or simply use the relationship between meridian angle and your LHA. So we have said before that if your LHA is less than 180 degrees, meridian angle will be equals to your LHA and it is named west. So in writing, if your LHA is less than 180 degrees, your meridian angle will be equals to your LHA and it is named west. Another thing, if your LHA is more than 180 degrees, your meridian angle will be 360 minus your LHA, and it will be named east. Okay? So, considering your meridian angle now, it is 50 degrees east. Therefore, it is understood that your LHA is more than 180. So, you just transpose this one. LHA now will become 360 minus meridian angle. So, 360 minus meridian angle of 50. Your LHA is 310 degrees. Okay, later on you will be asked also for your polar distance. So, from the first discussion of the celestial sphere and equinoctial system, we already have said that polar distance plus declination equals 90 degrees. Therefore, we are given declination. So, let's put in writing. Declination plus polar distance equals 90 degrees. So, we are looking for polar distance. Transpose this declination. Therefore, polar distance equals 90 minus declination. So, your declination is 30. Therefore, polar distance will be 60 degrees. Okay?